Hello and welcome to Sliver Implant Operations, the 18th video as part of our Red Team Fundamentals mini-series. Throughout the videos discussed so far, all of our operations have been conducted from outside the target system. That is to say, up to this point, all of our efforts have been focused on gaining remote access to the victim system. We have gathered comprehensive information about the target and employed several different techniques to phish them into executing our implant payload, and now we have remote control over them. Now, before we can understand how to attack the target system, we must first understand how to operate our implant, as all of our operations will be conducted through it. And in this video, we will discuss system navigation, whilst the next few will focus on more advanced concepts. As always, everything we teach in this video is purely for educational purposes. We accept no responsibility for your actions. Now, before we begin, I have separated this video into 4 parts. More specifically, we will be taking a look at 4 different categories of navigation and operations. We will start off by examining how to navigate directories and how to perform operations on the files that may be present within them. Following that, we will take a look at how we can download remote files to store locally, as well as how to upload files. And finally, we will take a look at how to execute system level commands, wrapping up our video. I have also created a cheat sheet that outlines every single command we cover in this video. You can find it in the description below. Now, you might remember from our earlier video on Sliver, where we set everything up, where we installed Sliver. You'll remember that every single connection from the implant back to the C2 server will generate a connection string. And inside this connection string, we have a very important value, which is the unique identifier of the implant. And whenever we want to use this implant, we will simply have to copy it, use the use command along with the implant's ID. And once so, you'll see that we are presented with the implant's interface, and basically any command we execute within it will be executed via the implant. And through this interface, we can essentially interact with the operating system. Now, one of the first commands we are going to discuss is called pwd. And what this command does is essentially prints the current working directory of our implant session. Now, this current working directory will be different per implant, and it will just depend on where your implant is executed from. And essentially, it just serves as a command to understand where we are within the system. Now, to traverse the folders of the hierarchy we may be present within, we can use the cd command. Now, the cd command requires us specifying a path of the folder where we want to change the current working directory to. Now, this can be specified in several different ways. One of those ways is enclosing a path within a set of single quotation marks. So as you can see here, we specify a path just as we would within any standard Windows system. Another way is simply by using 2 backslashes and then specifying the specific path we want to change to. And the reason we are using 2 backslashes is to escape the current backslash, because if we simply specify the path like so, Sliver will actually break and it will cause our command to fail. Because I believe actually the backslash is used for escaping commands into another line. So every time you use paths like this, just make sure you escape it beforehand. Another way you can specify a path is by using the Unix style /slashes. Now, this may be weird if you're operating within a Windows system, but it works. And lastly, if you are moving into another folder that may be present within the current folder, you don't actually need to specify any formatting at all. You can specify the folder name as is. Now, as with any standard Linux or Windows operating system, Sliver also supports the use of relative paths. And a relative path is simply used to navigate backwards through the folder structure. And to specify a relative path, we simply use 2 periods and a backslash. And this forms a single set. So for instance, as you can see, currently we are within the Google folder. And if we execute this command, you'll see that we move backwards to the local folder. And we can specify as many sets as we want. So for instance, if we specify 4 here, we should move all the way back to the C drive. Now, traversing all of this folder structure would not be complete if we did not list the files within them. And to list the files of a given folder, we can simply use the ls command. Now, by default, ls will list the contents of the current working directory, but you can specify a remote path as well. So if we execute it as is, you'll see that we get a listing of all of the files within the current folder. Now the ls command supports several different command line switches that can help us sort the output. So as you can see here, the M switch sorts by modification time. So if we use the M switch as part of our command, you'll see that the output now presents the most recently modified files at the bottom. And we can actually reverse this sorts order to print the most recently modified files at the top by using the R switch. So as you can see here, once executed, the most recently modified files are at the top of the output. Now, other than modification time, we can actually sort by the size of the file as well. And to do so, we simply use the S switch. So as you can see here, if we use the S switch, the most heaviest files will appear at the bottom of the output. And then if we want to, we can just simply use the R switch to print the most heaviest files at the top. Now, the ls command also supports several different filters that can help us filter the content that we are searching for. And most of these filters are pretty much in the same format as you would use with any standard regular expression. So say for instance, we wanted to search for files of a given extension, we can use the asterisk with the name of the extension we are searching for. So what this will do is it will match any file that ends with the extension name .dll. So once executed here, you'll see that we get two DLL files that are present within the working directory. I suggest that you have a look through some of these other filtering options you can use, but typically the asterisk is one you will be using the most. Now, of course, there will come a time where we want to view the contents of the files that we find, and to do so, we can use the cat command. And the cat command simply requires an argument that specifies the file that we want to view the contents of, or the path to that file. So as you can see here, we have a file named password within the secrets folder. And if we specify the path to that file as an argument to cat, you'll see that we get its contents presented back to us. Now, there are several different ways in which we can display the output. And one of those ways is in hexadecimal. And to do so, we use the X switch. So for instance, if we cat the file using the X switch, you'll see here that we get its plain text content on the right, and then on the left here we get its content in hexadecimal. Now you can also colorize your output, but typically this will depend on the file that you're viewing, and most of the time it will work with source code files or files like XML, but with something like a regular text file, it will not print any sort of colorized output back to us, as after all, it is a basic text file. Now, there may also come a time where you might want to move or rename a file, and to do so, you can use the move command. Now, although there's no specification of how we use this command, as the first argument, we typically specify the file we are renaming or moving. And then as the second argument, we either specify the name of the file that we are renaming it to, or we can specify the directory that we are moving that file to. And this is really important. If we are moving the file, we also have to specify the name of the file that we are moving, as otherwise it will attempt to rename that file to the directory that we are moving it to. So for this to make more sense, for instance, let me just try to move it backwards one folder, and you'll see that access is denied. And the reason for this is because move attempts to rename the file to a relative path. So if we wanted to move the file one directory backwards, we would have to include the name of the file. So if we list the contents of the current working directory, you'll see that the file is no longer present. And if we list the file of the directory that we moved it to, you'll indeed see that the file is there. Now, in the case that you don't want to move the file elsewhere on the system, you can actually use CP to make a copy of it. And many of the same arguments that apply for the move command also apply for the CP command. So for instance, if we were to move the password file one directory backwards, we can execute it like so. And if we now list the contents of that folder, you'll see that indeed the file is there. And lastly, if we want to remove a file or directory, we can use the rm command. So say for instance, we wanted to remove the file that we just copied backwards, we can use the command like so, and the file will be gone. So if we attempt to list the file again, you'll see that it's no longer present. Now, in the cases that you are removing directories, you will have to specify the R switch, and this will recursively remove all of the files and additional folders within that directory. So for instance, if we wanted to remove this secrets directory for whatever reason, we can simply specify the R switch followed by the argument that is the folder we are removing. And once executed here, you'll see that the folder is removed. And if we attempt to list it again, it will be gone. Now, in the cases that we are presented with such files like the password file, there may be times where we might want to download that file. Now, there is a better way of downloading sensitive files this way, and it is called looting, which we'll cover in the next video. But in the cases that we want to download files anyway, we can use the download command. Now, download supports several different options, but as the first argument will be the remote directory or file we are downloading. And then as the second argument, it will be the file that we are saving it as. And just to note that you don't actually need to specify the local directory that you are saving the file or directory to. It will save it within the current directory that you launched the Sliver client from. Okay, so let's say, for instance, we wanted to download the password file within the secrets folder. We would simply use the command as so. As you can see, we get a prompt here to overwrite the file as I've downloaded it earlier. I'll simply select yes. And if I open up another terminal here, list the contents of password, you'll see that it has downloaded successfully. And to view the contents of that file, we can simply use cat. Now, in the cases that you are downloading folders and all of its contents, you will need to specify the R switch. And what this will do is it will recursively download all the folders present within that folder or within the parent folder, that is, and all of the files that may be present within the nested folders of that parent directory. And if we don't specify the R switch, it will fail to do so, and it will only download the contents of that parent folder. And just to note that all of the folders that you are downloading, they are compressed using a tar file. So for instance, if we were to download the secrets directory like so, and to extract the contents, we can use the tar command with the xvf switch, and the x switch will simply specify the extraction operation. The V switch will enable verbose output, and then the F switch will specify that we are, or specify the file that we are extracting, and then also the file itself, obviously. Once executed here, you'll see that we get the file within the parent folder, and then we get the additional folder called nested, but not its files. Now, if we take a look at this nested folder within the secrets folder, you'll see that we have another file called another password. And as you can see here, this file was not included within this nested folder purely because we did not enable recursive downloads. So to download all of the contents, included all of the contents of any nested folders, we can simply use the R switch. And by using the same command for extraction, which we used earlier, you'll see that we do now get the file that was previously omitted. So whenever downloading folders, just remember to include the R switch. Now, in the case that we want to upload files, we can use the upload command. And the arguments for the upload command are pretty much the opposite of the download command. So we will be specifying a local file or folder we are uploading, and then the path to the remote file or folder that we are uploading it to. So for instance, say we have a DLL payload that we want to upload. Because this is in the uploads directory, we will have to specify that directory that is relative to the path where we executed our Sliver implant, and then obviously specify the name of the file that we'll have once the file is uploaded. So once executed here, you'll see that Sliver uploads the file, and if we list the file now, indeed you will see that it has been uploaded. Now, before we finish up on these two commands, I just quickly want to note the way that these files are uploaded and downloaded. It is done so using the same Sliver connection that is established within the server. So say, for instance, you are using HTTP as your communications protocol, all of your downloads and upload operations will be handled within the same protocol. Now, this is important because if you're using something like DNS, which is very, very slow as a communications protocol, it can take a significant amount of time to both download and upload files. So just keep in mind the protocol that you are using. And because we are using HTTP in our case, the download and upload operations are pretty quick. Now, one of the last few commands we will take a look at is called execute. And as its name says, it essentially executes anything we provide as an argument on the system. And this is quite useful for executing native Windows commands. Say, for instance, you are using native Windows software to perform your red team operations, or as it is otherwise known as living off the land, execute can help you achieve this. Now, one thing to note is that when you are using execute or shell, which we'll get into shortly, it's pretty bad OPSEC. And the reason for this is because once we execute one of these commands, it spawns a new process, runs that command, and then the process terminates. So just to better illustrate, because our implant is being executed through the run DLL32 process, which is used to execute DLLs, you'll see that one of the DLLs that it has loaded is the implant we previously generated. So if we filter down within process monitor for operations, if I can find it, where's operations here? Operation is, then we'll specify process create. So what this will do is it will include only those events within process monitor that match process create. We'll select add. You'll see here that it is included. And also I am going to include the process of which is running our implant as well. So we'll select process name is, and that will be run DLL32.exe. So what this filter will do is it will list all process create operations from the run DLL32 process. And this will allow us to see all of the processes that are created from the execute command in which we run in Sliver. So I'll just select apply, okay, and I'll start monitoring. So back within our Sliver C2 console, I'll simply use execute to execute something like notepad.exe. Now, if we go back into process monitor, you'll see that indeed run DLL created a new process that was notepad. And many EDRs today monitor for such behavior, and from something like run DLL, it should have no business of launching notepad.exe. And if we actually view the process tree of this event, you'll see that run DLL spawned a notepad.exe as a child process, and it's currently actually running as well. So I'll just close that off. You'll see the PID that it gets assigned, when it was started, and stuff like this is only artifacts that we leave behind for the blue teamers to detect. Now, there will come a case where we do need to run commands this way, and when we have no other alternative, we have no other option. But when we want to view the output of those commands that we run, we can use the O switch. So for instance, if I was executing something like cmd.exe and a command like who am I'll actually need to provide the C switch for cmd as well. And if you see, if we execute it like this, we won't get any output. Now, to include the output, all that we need to do is simply include the O switch. And as you can see here, CMD will execute and it will present back the output to us. Now, there are other numerous options which we'll get into later in this mini course, but have a play around with some of these options. You can actually spoof parent process IDs. You can also hide windows as well, and many other options that I will leave as an exercise for you to explore. Now, in the case that we want an interactive shell with the system, we can use the shell command. And much of these same OPSEC principles that apply for the execute command apply for the shell command. But what the shell command allows us to do is to launch an interactive prompt through which we can then interact with a native Windows interpreter such as CMD or PowerShell and run commands through it. And as you can see here, Sliver itself raises a prompt that this is bad OPSEC and that we should reevaluate our options, but we will select yes. And as you'll see here, another session establishes that is a direct interactive shell that is the system. And then any native command that we want to execute, we can do so as is. So for instance, with PowerShell, I could use something like get child item to list all of the files within the folder and other commands that you may want to use, whatever that may be. Now, once you're done with the interactive session, to terminate it, you can use Control+D, and you'll see here that the shell will exit in a neat manner. And that concludes Sliver implant operations. By now, you should be well equipped to use an implant to perform various system level operations, from navigating directories to executing system commands. In our next video, we will explore Sliver's looting capabilities, which will enable us to store information for later use, both for ourselves and for our other fellow Red Team operators, to facilitate more effective collaboration. Furthermore, feel free to join our Discord server, for which you can find a link to down in the description below, where you can keep up to date with us, chat, contribute, and soon participate in some exciting practical content we have coming up. Until then, stay safe, over and out.